My main research interest focuses on the control of human movement. So how do we move our bodies around when we're walking, running, when we play games like table tennis or soccer, trying to figure out how people use their brains to control their bodies, and then when things go wrong, like with stroke or spinal cord injury, how can we use technology to help them relearn how to walk again? So over the years, I've developed that interest to include lots of different approaches, but we're really still trying to understand how people learn to do certain movements, and then when they have injuries, what's causing those injuries, and then how do you rehabilitate them faster. So this is the Human Neuromechanics Laboratory, and we study human movement of all forms. So we have special treadmills that allow us to measure the ground reaction forces. They're like force sensors that tell us how much you push against the ground. We have lots and lots of cameras that are around the lab that film the movements of people so that we can take those movements and turn it into quantitative analysis. We also have lots of other sensors we can put on people's bodies. Some of them sense electrical signals, like electrodes that we put on your head over your hair that we can sense the electrical signals in your brain. We have other electrical sensors we put on your skin over your muscles that sense the electrical activity when you activate your muscles. And then we have motion sensors that we can put on people to sense how they're moving their bodies in acceleration and position. So they basically allow us to take a subjective analysis. So if you're watching the Olympics and you're a judge, you're using your eyesight to watch how the gymnast moves, and you're translating that into a score. What we do is take the motion of people and not only take what we see with our eyes, but also the electrical activity that they use to activate their muscles, the electrical activity in their brain, and then we convert that all into quantitative numbers. So instead of just giving a 9.6, we can actually analyze how they're moving their bodies, what comes first, when they sense there's a problem with their motion, and which muscles do most of the work. There are lots of examples of us trying to learn new movement patterns. When we try to learn a new dance is a great example. Some people pick up a new dance really quickly, and other people pick up a dance more slowly. What is the difference between the people that are learning quickly and more slowly? And we can film them and get their motion patterns and do what the judge sees and sees that one is better than the other. But we're trying to look at the mechanisms behind why people learn faster rather than slower. And so by using the split belt treadmill, it's sort of a litmus test for general motor adaptation.